Okay, here are the answers to the questions from the last chapter on kinetic theory. Hopefully you got them all right. Now we're going on to transferring energy by heating. Infrared radiation. Now this is the part of the electromagnetic spectrum that's just beyond the red part of the spectrum. So looking at the rainbow of colours there, this is the visible part of the spectrum. These are the colours of light that we can see. And infrared radiation is just beyond the red part of the spectrum. We can't see it, but we can feel it as heat. For example, we can feel the warmth from a hot oven. Every object emits, which is the proper term for saying gives out, infrared radiation. And the hotter the object is, the more infrared radiation it emits. Infrared radiation transfers energy. This is a term that we'll be using a lot in this unit. It's able to heat up the surroundings and other objects. Dark matte surfaces are the best at emitting and absorbing infrared radiation. Light shiny surfaces are poor at emitting and absorbing infrared radiation. But light shiny surfaces are better reflectors of infrared radiation. The thing to remember about infrared radiation is that it doesn't require a medium, in other words particles, to travel through. So it can travel through a vacuum. In fact, it can travel through space from the sun. Conduction. This is one way in which energy is transferred through solids. When particles in a solid are heated, they gain energy. In fact, they gain kinetic energy or movement energy. Since these particles are in a fixed position in a solid, they vibrate, but the vibrations are of increased size and frequency. So the particles therefore bang their neighbours, and this causes neighbouring particles to vibrate, and the energy is therefore transferred throughout the solid. So the diagram shows particles being heated at the bottom there, and these particles gain energy. Their vibrations become bigger and more frequent. They collide with their neighbours, causing their neighbouring particles to vibrate, so the energy is transferred throughout the solid. Conduction in metals. Metals are the best conductors of energy, and the reason is because they have free electrons, which are subatomic particles. The free electrons are able to move around inside the metal and around the metal ions. So when they're heated, the electrons gain kinetic or movement energy. The electrons therefore spread out throughout the metal, and the energy is transferred to other electrons and to metal ions. Convection. Now this occurs in fluids, which is gases and liquids, things which are able to flow. As parts of a fluid are heated, the particles have more energy, and because they gain kinetic energy, because their movement is increased, they move away from each other. Now because they move away from each other, they become less dense. And because they're less dense, they rise. Now if they rise and move away from the source of the heat, they'll then cool. So when they're cool, their movements decrease, they move closer to each other, so they become more dense and they fall. It's called a convection current. So this transfers energy from the hotter parts to the cooler parts of the fluid. So this diagram shows a convection current in action. As parts of the fluid are heated, they become less dense and they rise. When they reach the top of the fluid, they cool. The particles move closer together, they become more dense and they fall. They get to the bottom, to the source of heat, and they get heated again, and so on in a current. Remember, These both, and I'm talking about conduction and convection, require a medium. They require particles to travel through. So they can't travel through a vacuum. So in this way it's different from radiation. Okay, so quickly test yourself. Hopefully you've printed out all these notes so you can answer it now and find the answers at the beginning of the next chapter.